Alright, in today's video we are looking at an introduction to solution concentrations using molarity for grade 11 chemistry. You're supposed to be trying this for homework, or you can be using this as a review for a test or an exam. So question number 1 says, what is the sodium chloride concentration, the molarity, if 0.658 moles of sodium chloride is dissolved in 2.50 liters of water? This is about as easy of a question as you can find. We have a formula for concentration. Concentration is moles divided by volume, or C equals N over V. The volume in this formula has to be in liters, and then we'll get a unit of moles per liter, which is called molarity. So in this question, we know the moles of salt, we know the volume of the solution, so we're going to divide those. So 0.658 moles of salt, sodium chloride, divided by, now just looking at the wording of this question, there's a little bit of something that's not quite right. It really shouldn't say in 2.50 liters of water. It really should say to prepare 2.50 liters of solution, because the formula is moles divided by volume of solution, not the volume of solvent. Technically, if you were to measure 2.5 liters of water and then add your salt, the resulting volume would be slightly higher than 2.5 liters. The salt would make the water level rise slightly. So a better wording in this question would have been to dissolve the sodium chloride to make 2.5 liters of solution. In any case, we'll assume that's what it meant. So 0.658 divided by 2.5. I'm going to keep 3 significant digits in my answer, and I get 0.263 moles per liter, or you could just say 0.263 and then put a capital M, which means molarity. Now some people get confused because a capital M in other situations meant molar mass. For example, when we say moles is mass over molar mass. So the difference is that this big M is part of a formula, and it stands for molar mass. This big M comes after a number, so it means it's a unit. And as a unit, it's not molar mass, it's molarity, or moles per liter. Question number 2, what is the resulting molarity if 78.9 grams of calcium bromide is dissolved, again the wording is a bit off, to prepare 2.0 liters of solution would be a better way to say that. We could do this in formulas. In fact, if you like to do formulas, you would first find your moles of salt using the formula I've already mentioned, the mass divided by the molar mass. So you'd say 78.90 grams divided by the molar mass of calcium bromide, which you would get from a periodic table. It turns out to be 199.88 grams per mole. And dividing that, we'll keep 4 significant digits, 78.90 divided by 199.88. This is 0.3947 moles of calcium bromide. And now you would use your formula, concentration is moles divided by volume, to say 0.3947 moles divided by 2.0 liters, and we'll keep 2 significant digits in this answer, and we get 0.20 molarity as our final answer. Another way to do this would not have used formulas. It would have used unit multipliers. So what I could do is to start with the mass, 78.90 grams of calcium bromide, and with 1 unit multiplier, we'll switch the grams to moles of calcium bromide. Using its molar mass, 1 mole is 199.88 grams. Then we realize that we were trying to find a concentration, which is moles per liter, or in other words, moles divided by the volume. So with another unit multiplier, we're simply going to divide by the volume. This is a little bit strange because most unit multipliers that we've used so far have converted from one unit to another. In this case, I'm not going to convert I'm not going to convert from one unit to another. I'm simply going to divide by volume, and the volume in the question was liters. So now if you look at my units, the grams cancel, and I'm going to be left with moles per liter, which is molarity. The volume was 2.0 liters, so that's how I would set this up using unit multipliers, and I'll get the same answer, 0.20 molarity. If you compare the unit multiplier approach to the formula approach, you realize we're doing the same things. We're taking the mass and dividing by the molar mass, and then we're taking that and dividing by the 2 liters. All right? Question number 3, what is the, and it's got this square bracket symbol. Square brackets, when you see that around a formula, means molarity or concentration. So this is asking what is the concentration of Ki when 3.45 grams of the potassium iodide is mixed with 1.25 liters of water. And again, we'll assume that means to make a solution whose volume is 1.25 liters. So you could do this exactly the way we did above using formulas or using unit multipliers. I'll do it using unit multipliers. So 3.45 grams of potassium iodide. My first multiplier will switch the grams into moles of potassium iodide, and then I'm trying to find the concentration. So once I have the moles, I just have to divide by the volume, and the volume here was given in liters. So putting my numbers in, the molar mass of potassium iodide using a periodic table is 166.00 grams, and our volume of solution was 1.25 liters. So 3.45 divided by 166.00 divided by 1.25 will keep 3 significant digits in the answer, 0.0166 molarity, or moles per liter. And you can write either moles per liter like that, or 0.0166 molarity. Okay, the fourth question, again, square brackets around a formula means concentration or molarity. So what is the concentration of calcium carbonate when 123.6 grams of calcium carbonate is dissolved? And again, we'll assume this means to make 975 milliliters of solution. So this time I'll use formulas. The moles is the mass divided by the molar mass. So that's going to be 123.6 grams divided by the molar mass of calcium carbonate, 100.09 grams per mole, using a periodic table. So 123.6 divided by 100.09, this is 1.235, 4 significant digits, moles of calcium carbonate. Okay, and we're going to dissolve this to make 975 milliliters of solution. Concentration is moles divided by volume, and that's equal to 1.235 moles of the calcium carbonate divided by the volume, but the volume has to be in liters. So in this question we would have to take the 975 milliliters and with 1 unit multiplier switch your milliliters to liters. There's 1,000 milliliters in a liter, 0.9750 liters. So put your 0.9750 liters in there, and we get concentration is 1.235 divided by 0.9750 is, with 4 significant digits, 1.267 molarity. Okay? Now I'm going to show you how to do that same question using unit multiplier, because there's a little bit of a quirk at the end. So I'm going to solve that same problem. I'm going to do it down below here using unit multipliers. So I would have taken the mass, 123.6 grams of the calcium carbonate, and with my first multiplier I would switch the grams to moles of calcium carbonate. 1 mole is 100.09 grams. And then, once I have moles, I remember I need to divide by the volume. But in this question that we were in, number 4, the volume was in milliliters. So all I'm going to do is divide by that volume, 975.0 milliliters. And then with one more multiplier, I'm going to say, well, milliliters were supposed to have been liters. So I'm going to make these milliliters disappear by putting milliliters on top of this unit multiplier. When one's on the bottom and one's on the top, they will cancel out. And I'll switch the milliliters to liters. So when I cancel these units, the grams are gone, the milliliters are gone, and I'm left with moles per liter. And that last unit multiplier, there's 1,000 milliliters in a liter. So 123.6 divided by 100.09 and divided by 975 and times 1,000, and you get the same answer we had above, 1.267 moles per liter, or 1.267 molarity. All right? So now that particular question irritates me as well, because calcium carbonate is actually chalk or limestone, and it would not dissolve like this in water in real life. But supposing it did, that would be the concentration of the solution at the end. All right? So there's 4 examples of solving simple concentration problems using formulas and using unit multipliers.